Hey, welcome to another episode of TK's Tech Corner, where we look at all things techie for the average user. So I'm excited about today's video because I get a chance to share with you all something that I've been working on for quite some time now. It's gone through a couple different iterations, and I just want to share with you all where it is at its present stage. So without further ado, I introduce you to my homemade bonding router. So if we go ahead and take a look at it here, we see that I have it in a Pelican style case. This is a inside shot of the components. Give you guys a side view of it. I'm not sure what size case this is. Let me see if it's on here anywhere. Yeah, the size of it's not on here, but this, I believe this is a medium-sized case, Pelican style case. So I just want to share with you all how this project started. It started from me needing a reliable internet connection for live streaming. This happened around the time when the pandemic hit. The location that I was streaming from had a slow DSL internet, and it wasn't possible to get a faster hardline connection. So we tried to go the route of using a mobile hotspot. We started off with the Nighthawk M1, but even that had connection and speed issues. So that led me to try to search for a device that could bond multiple internet connections together into one reliable connection. And I came across an application called Speedify that could run on a Raspberry Pi. And since I had already had somewhat of an experience with Raspberry Pi, and I had some extra Raspberry Pi parts laying around, I decided to try to build my own bonding router. And thanks to Alex Patet, I believe it is, his video tutorial, I was able to build my first iteration of my bonding router. I'll put the link to the video in the description. Since starting and building and using the router, I've added new parts and retired old parts to come up with what I'm going to show you today. So let's take a look at the main components that makes up this bonding router. We're just going to look at the main components today because I'll make another video which will give you details of each individual part, because as I was going deeper into the build, I ran into a couple different issues that could only be solved by buying new special parts to meet the demand in the system, mainly the power demand. But I'll get into those particulars in the other video. So what we're gonna look at first is the brains of the system, which is the Raspberry Pi. So let me pull up that top-down view so you guys can take a look. So the Raspberry Pi is situated here. You can't actually see it because of the top hat that's on top of this unit, but the Raspberry Pi is at the bottom. The Raspberry Pi runs the Speedify application natively on the Raspberry Pi OS. That's the main component. That's one of the main components. That's the brains of the system. The next component is a travel router, here, situated here. You've seen me talk about this router in previous videos, so go check those out to get more details about it. It's the GL-iNet Slate AX router. Another part that's not necessary after initial setup, but is useful for the on-fly diagnostics and settings changes, is a monitor. So let me give you guys the viewpoint of that also again. Okay, that will be here. It's built into the case, the top lid of the case. This is a 10-inch monitor that I had left over from a Raspberry Pi project kit that I had bought my son a couple years back. Now going back to the top-down view, if you look here in the right-hand corner of the unit, is the power supply. This power supply is a 5.1 volt 10 amp AC to DC adapter. Another way that this unit is powered and also provides uninterrupted power is a UPS top hat card for the Raspberry Pi, which is what you see directly situated right here. So that provides power for the entire system. For one of the internet connections, I have a USB to Ethernet adapter right here. And then I have two USB modems, which you have seen in my other videos. These are the Inseego USB 800s. So this is the main hardware that makes up this bonding router. So let's look at how all this is set up. Let's first look at the internet connections that will be combined to provide the bonding connection. So like I said, first we have two USB modems with SIM cards. One has a T-Mobile SIM, the other one has a Verizon. And those plug into the top of the unit. Let me pull up that shot. They plug right here in the top of the unit. Let's see if we can switch to this shot. You guys can focus. So yeah, if we switch that shot, you can see that the two USB modems plug right here, directly in the top of the unit. Like I said, one has a T-Mobile card SIM, one has a T-Mobile SIM, the other one has a Verizon SIM. The next connection is a hardline Ethernet connection, which if we go back to the top-down view, we can see that right here. So I'm gonna actually plug this in for the hardline connection. So all three of these connections are connected to the Raspberry Pi via USB. Another internet connection for internet bonding is the built-in Wi-Fi on the Raspberry Pi itself. Now it can be used to pick up Wi-Fi hotspot signal or connection. So all four of those internet connections, they're going to be used for the bonded side connection. For the side that is going to make use of that bonded connection is the built-in Ethernet port on the Raspberry Pi, and that's actually situated right here. Like I said, it's already a port that's connected to. That's already a port that's on the actual Raspberry Pi itself. From the Raspberry Pi connection out, we want to use this connection, like I said, to provide internet to whatever device is connected. What I have it routed to is the mobile router. It's routed into the WAN port of the mobile router. Now you don't have to route this connection to a router. You can directly plug the connection into whatever device that has an Ethernet port to share the bonded connection to connection with it. But I wanted to have at least two LAN connections and also a wireless connectivity to the bonded connection. So using the travel router gives me that ability. So I'm able to hardwire two streaming encoders. So like once again, if you look at the back of this router, if you haven't watched the previous videos, it has two LAN ports. So I'm able to plug in two streaming encoders into the back of this thing, but also connect any wireless device to it also. So with two encoders connected, I have one main encoder and then I have a backup encoder attached to the system. So let me pull this up. Let's get a side view of this again. So as you guys can see in this shot, I have a YOLOBOX Pro. So with this, I use this as my main encoder doing a shoot or doing a stream. Now I also have an ATEM Mini Pro ISO, which also can stream directly to whatever platform I want to stream to. So I can use that as a backup just in case the YOLOBOX fails. For anyone who who's in the YOLOBOX ecosystem knows that we have had issues with reliability. So to combat that issue, and the reason why I wanted to build a bonding router outside of, natively trying to run Speedify on the YOLOBOX Pro itself, which you're able to do. It's a workaround to get that working. But I wanted also to have a bonded connection for my ATEM Mini. So just in case if I wanted to run the ATEM Mini separately by itself, I wouldn't have to, I would be able to run it directly from this unit here. So with the bonded side of everything, like I said, I have 3 connections, a possible 4, which is the Wi-Fi hotspot I can use on the Wi-Fi connection on the Raspberry Pi itself I can use. So I can theoretically have 4 connections. It's a possible maybe for a 5th connection if I was to add either another USB Wi-Fi card, which I haven't tried because I usually don't use Wi-Fi for streaming. But I possibly also could have another Ethernet hardline connection using another USB Ethernet to USB adapter. So that's basically the connection side of everything. Now, one of the features that I wanted when I started this build was to be able to power not only from an AC plug, but also to be able to be mobile and be battery powered. It took some time and effort to figure this out. It took some time and effort to figure this out, but the entire unit can be wall power and run off of batteries, which allows this unit to be used in more application in different environments. Now, since we looked at the hardware part of everything, let's take a look at the software side of things and how the Speedify application delegates what connections get used for bonding and what connection is used to provide the bonded connection. So I'm gonna open this back up. I'm gonna give you guys, show you the software itself running on a Raspberry Pi. So we have to give it a moment for it to come back to life. All right, just give me a second. All right, there we go. I had to find the cursor. So if we look at the Speedify application, we see that it's running. In this area here, you'll see network traffic if we had any. What I'll do is I'll open up a web page real quick on my iPad, which is connected to the router, the bonding router, so you guys can see the network traffic. All right, so you guys seeing that little spike there, right there, lets you know, that shows you all the traffic that's going over each individual network. So how Speedify works with the network connections, you have to delegate, you have to tell it what connections you want to use for the bonding side and what connection you want to use for the side that's going to accept the bonded connection. So as you can see, if we look here, our first connection is the Ethernet connection, which is that Ethernet to USB adapter that's plugged into the Raspberry Pi. That is an AT&T fiber connection. The next connection you will see is one of the USB modems. This is the T-Mobile modem that has the T-Mobile SIM card in it. The next one is the other USB modem, which has the Verizon SIM card in it. As you can see, all three of these connections here are highlighted. The very bottom connection is grayed out. That connection is the Ethernet port that is on the Raspberry Pi, built into the Raspberry Pi itself. So that port is what we are using for connection to the bonded side of the network. So that connection we have set aside to provide the bonded connection. So that's why it's grayed out. So that's the basic setup of how Speedify is delegating all the connections that I have attached to it. Now, if I was to add Wi-Fi, you know what? Let me do that real quick. So I'm gonna add a Wi-Fi connection really quick. Let's see if it works. All right, so I just turned Wi-Fi on, and in a minute you should see that connection pop up. All right, let me see what we got here. All right, so I'm not sure why that's popping up. It's saying something about a torrent, but I don't have any torrents open. All right, never mind. We're gonna disconnect from that, so because that's messing up something. All right, so yeah, we're not gonna worry about that, but it usually does work to where we are able to use a wireless connection. I'm not sure if I got something attached to this that's causing it, but yeah, so those are all the connections that we have. Now to go into some of the other settings that are available, we'll run over it real quick. I won't get into detail, but here you can set your bonding mode. You can set it for speed, redundancy, and have it checked off for enhanced streaming, which I do, and I have it set up for speed. Some of the other settings that I like to have access to is the transport mode. You can set it to auto. Auto does work sometimes, but depending on your networks, if you have two different networks that have that varies greatly in speed, using automatic does not work well. You have to either set it to UDP or TCP, usually UDP, for networks that are far apart in speed. And sometimes it won't work at all if the two networks that you are using are far apart in speed. For bonding, it's better to have networks that are close in speed and bandwidth. Now, what I like about Speedify is that you can test your internet connections, and it would tell you at what quality and frame rate that you can, max frame rate that you can actually stream over the network. So I'm gonna show you guys a test. I'm gonna run the test real quick so you guys can see how that works. So right here it says start live streaming test. So we're just gonna hit that. So what it's doing right now is just running a live stream test, and it may take a few moments for it to go through its thing. If I scroll to the top, actually you'll be able to see the network data, traffic going over the network. So if we look here, with all three of those connections, it says that we can run 4K video at 60 frames per second. That's great. For most of us, we're not streaming at 4K. We're most likely streaming at 1080p. Some may be even streaming at 720p still. But we have well over enough bandwidth to be able to live stream. So, yep. All right, sorry, y'all, I'm gonna pull this out. But yeah, we have more than enough bandwidth to conduct a solid live stream. So that's a partial look at how the Speedify application works. So to wrap up this video, I'm pleased with how this project turned out. For me, it's been useful in what I need it for. It was just really a fun project to work on, to put it together and problem solve as problems arose. I'm a tinkerer by nature, so I enjoy putting it together. I'm not sure if this was cost effective in comparison to buying an already built bonding router, just because I haven't added up all the costs of the material. And like I said, some of the things that I used were parts that I had already lying around. But nonetheless, I'll try to get you guys the full build cost in the next video when I explain each component individually. But that's pretty much it for this video. I know it ran kind of longer than I wanted it to, but like I said, I'm just so excited and pleased with how this project turned out, from where it started from to where it is right now. And that ends this episode. Until next time, I'll catch you later.